today we're going to finish up Chapter 5, Section 4. Today we're going to focus on solving the log equations. So yesterday we did the exponential equations, and these are suggestions on how you can solve an exponential equation. We did some examples, additional examples, and here we are. So in order to solve a log equation, if you only have one log in your equation, you can just turn it from A to B and then solve, which is what we've been doing in the lessons before this. If you already have one ln, you can either use those properties. You could also choose to change it to a log with a base e and then convert it to exponential form. What we're going to do is if I see an equation with an ln, I'm just going to keep it the natural log, and then I'm just going to change it to exponential with a base of e, and then it's a calculator problem. If you have one log on either side of the equal sign, we can use our one-to-one property and then just cancel out the word log and solve what remains. However, if you have more than one log word on both sides, we must use our properties to condense. You can't just cross out every time you see the word log if you've got more than just two. And we're going to see this coming up. Now remember, once we solve for these variables, the base of the log cannot be negative or a zero or the number we're finding the log of. So on these log equations, after we solve them, we need to make sure it's not making anything negative when we plug it back in. And we're going to see that coming up. So let's go ahead and do some examples. So the first one, it's a natural log. So all I'm going to do on this one, instead of changing it to a log, I'm just going to change it to exponential. And remember, the base of the natural log here is an e. So right now it's spelling bay, and I'm going to go to b. So I'm going to do e to the third power equals x. This will be a calculator question. Now the e with the exponent, it's on that first row of buttons on your calculator. It's the ln button, third button from the bottom, far left. You have to hit the second key, then ln, and then you can raise e to a power. So you're going to hit second, and then you'll hit the ln button, and then we'll put 3, and then hit enter. And the decimal we're getting is 20.08553692. I'm going to round to 4 places. The 3 tells the 5 to stay the same. So 20.0855 will be your value of x. Notice it doesn't make anything negative. So let's try the next one. Same thing. Remember, you have got an assumed little e here. So e squared equals x. Again, calculator. You're going to raise e to the second power. Use your calculator, and you get x is equal to 7.389056099. We're rounding to 4 decimal places. The 5 tells the 0 to go up. So 7.3891. When you go to check your PDF answers after I post them tomorrow, all of my answers are going to be rounded to 4 places. When you take the test on this next Wednesday, a week from today, just read the instructions on the place where I want you to round. The next one, notice I've got the word log with a base 3 on the left side of the equal sign and on the right side. So I can use my one-to-one property, and I can get rid of the log base 3 and now set what remains equal to each other. So 5x minus 1 equals x plus 7. I'm going to go ahead and solve for x by subtracting and getting my like terms together. I get 4x minus 1 equals 7. Add the 1. 4x equals 8. Divide by 4. And x equals 2. Now, because my equation started out as a log, I need to make sure that when I plug it in, it doesn't make anything negative. So really, all I'm plugging it into is the 5x minus 1 and the x plus 7. So when I plug in a 2 here and here, I get 5 times 2 minus 1. 10 minus 1 is 9. Over here, 2 plus 7 is 9. It did not make anything negative, so x equals 2 is a good answer. So remember, the only way to use the one-to-one property is when you have a single log on the left and a single log on the right side of the equal sign. So the biggest mistake I see is everybody thinks, oh, it's the same log. Let me just come here and go cross, cross, cross and solve what's left. If you do that, you will get it wrong. So whenever you have more than one log on one side of the equal sign, whenever you have more than 2 logs, you have to condense. So I need to condense. The subtraction sign here tells me that this is going to turn into a division problem. So I'm going to write the word log base 6 one time, and then I'm going to take the 3x plus 14. It goes to the numerator, and the 5 to the denominator. I'm trying to condense it down so it only has 1 log base 6. Now the right side was good. Nothing to condense, so log base 6, let me write it over here to the side, because it's going to go into that blue. So log base 6 of 2x. Now I can use my one-to-one property and get rid of the log base 6's. And now you're going to solve what remains. So I'm going to take the blue, 3x plus 14 over 5 is equal to the 2x. Now, I'm going to go ahead and solve this as a proportion. You could just multiply both sides by 5 to get it out of the bottom of the fraction. I'll just do that on this one. Multiply both sides by 5, cancels the fraction, and now I'm solving 3x plus 14 is equal to 10x. And now I'm going to subtract the 3x, get my x's together. 14 is equal to 7x, divide by 7, and x equals 2. Again, I need to check it. But again, the only thing I'm checking, and let me write it down here. This is the original problem. Remember, the only thing we're looking for is to see if we're making anything negative. So I'm not trying to make the 2 sides equal. I'm just checking for negatives or zeros. So when I plug it in here, I get 3 times 2 plus 14. 6 plus 14 is 20. No negative there. Nothing to plug in here. And then when I plug it in here, 2 times 2 is 4. It didn't make anything negative. I'm not trying to make these 2 numbers equal to each other. I'm just making sure that it doesn't turn it negative or make it a 0. So x equals 2 is a good answer. Okay, so for the next one, notice this one, nice and easy. I can go right to my one-to-one property. All I have to do is get rid of this log base 2, and then now I'm going to solve what remains. So the 2x minus 3, set it equal to the x plus 4. I need to get my like terms together, so I'll subtract x from both sides. I get x minus 3 equals 4. Add the 3, and x equals 7. Again, I got to check it. So when I plug it in up here for this x, I get 2 times 7 minus 3, 14 minus 3, I get 11. It's not negative, it's not 0, so far so good. And then now plug it in here as well. And 7 plus 4 is also 11. So x equals 7, good answer. Okay, number 18. Again, do not be tempted to say, I'm going to cancel this, this, and this, and then solve what's left over. Do not do that. You will get it wrong on the test. We need to make it so that there's only 1 log on the left, 1 log on the right. So this subtraction sign here means division. So I'm going to combine it to a division problem. So it's going to be log 4x over 12 plus x equals log 2. Again, I've got the same exact log on the left side that I do on the right. Get rid of that word log, and now solve what remains. So now I have 4x over 12 plus x equals 2. Now I'm going to go ahead and do this one as a proportion, just to show you could do it this way as well. Otherwise, what you would have to do is multiply both sides by the 12 plus x. So another option is add a 1 to make that 2, that whole number 2, a fraction. I need to do the cross products. So 4 times x will give me 4x. And then I have to distribute the 2 to both the 12 and the x. So now I have 4x equals 24 plus 2x. I need to get my like terms together. So I'm going to subtract 2x from both sides. And I get 2x equals 24, divide by 2, and x equals 12. Now I got to check it, make sure that it doesn't make anything negative or a 0. So when I plug it in up here, I get 4 times 12, and this gives me 48 for the first one. And then 12 plus 12, that's 24, and then nothing to plug it into the right side. So it didn't make anything negative, anything a 0, so x equals 12 is a good answer. All of these would be non-calculator questions, both of these. All right, so I need to get the log all by itself. So the first thing I need to do is subtract the 5 from both sides. I get 2 ln x is equal to -1. I still need to get that natural log by itself, so divide by 2, and ln x is equal to -1/2. Now remember, this is in log form. I can now go to exponential. So remember the assumed base here is an e. So e to the -1/2 power equals x. Calculator. So you're going to hit the second key, that ln button to raise e to a power, and then put it in as a -1/2 exponent. Remember, when you're doing the negative, remember, don't use the subtraction sign. You need to use the negative sign that's down there by the decimal point. So once you do this on your calculator, you're going to get x rounded to 4 places, 0.60653066597, 4 places, sorry. The 3 tells the 5 stay the same. So 0.6065 would be your answer. Next one, exactly the same thing. Isolate that natural log by subtracting the 7 from both sides. 3 times the natural log of x equals -2. Divide by 3. Natural log of x is equal to -2/3. It's in exponential form. Spelling bay, we're going to go to b. Again, remember the little assumed e here. So now it's e to the -2/3 power equals x. Again, calculator question. Remember, you can enter a fraction by hitting the alpha y equals button, or the newer calculators, you can also hit alpha and then the button right to the right of it, that x. And then once you do this on your calculator, you should be getting 2/3. We're getting x is equal to 0.513417119, rounded to 4 places, 0.5134. Now remember, a negative exponent doesn't make the answer negative. Remember, it makes it a fraction or a decimal. And notice my answer is a decimal here. So a negative exponent really is turning it into fraction, or in this case, we're listing it as a decimal. This one's going to be the same thing, but instead of natural log, it's log. We need to get the log all by itself. So we need to divide both sides by 2 first. And then I get log base 5 of 3x is equal to 4 divided by 2 is 2. Is spelling bay, I'm going to put it into b. So 5 squared is equal to 3x. 5 squared is 25 equals 3x. Divide both sides by 3. And x is equal to 25 over 3. You can leave it a fraction. Just make sure it's reduced. When I plug that in, it's not making anything negative. Let's try the next one. Same thing. Isolate the log first. So divide both sides by 3. Log base 4 of 6x equals 3. It's spelling bay. We're going to go to b. So 4 to the third is equal to 6x. 4 to the third is 64 equals the 6x. Divide by 6. And x is equal to 64 over 6. But I can reduce that. I can divide them both by 2. So 32 over 3. And again, it's not making anything negative. Next, plus sign. This tells me that this is going to be a product. So I'm going to be multiplying. So I need to write the word log one time, and then I'm going to multiply these two. So 5x times the x minus 1 equals the 2. I need to distribute that 5x. So log 5x squared minus 5x equals 2. So this is what we're finding the log of. Remember, when there's no little base here, it's assumed to be a 10. Spelling bay. So right now I have BAE, and now I'm going to go to exponential and go to BEA. So 10 squared is equal to 5x squared minus 5x. I need to set it equal to 0. So I need to do 10 squared, which is 100. I'm going to move the 100 over by subtracting it. And now I have 0 equals 5x squared minus 5x minus 100. I can factor out a GCF of 5 before I start factoring that trinomial. Once I pull the GCF out, now I have 5 and then x squared minus x minus 20. I need to find factors of negative 20. That will give me a negative 1. Those factors are going to be a negative 5 and a positive 4. Set each of the factors equal to 0. So when I set the GCF equal to 0, there's nothing to solve for here. So I don't do anything with that. If the GCF had a variable, it would have given me an answer. But now I need to do the x minus 5 equals 0, the x plus 4 equals 0. Add 5, x equals positive 5, and x equals negative 4. Remember, my original problem started out as a log. Let me go ahead and rewrite the original underneath here. So when I plug in 5 in for all of these, so if I plug this one in, it's 5 times 5, 25. 5 minus 1 is 4. This one's good. But if I plug in negative 4, 5 times negative 4 gives me negative 20. Soon as it makes one part of the problem negative, get rid of it. And the only good answer here is the x equals 5. So this one we also have to condense. The plus sign means product. So log x times x minus 9 equals 1. I got to distribute. So x to the x is x squared. X to the 9 is 9x. Again, it's got the little assumed base of 10 here. Spelling bay. I'm going to B. So 10 to the first equals x squared minus 9x. And then now I need to move this over. I need to set it equal to 0. And now I got to factor again. Factors a negative 10. That give me negative 9. And that's going to be a negative 10 and a positive 1. Set each of the factors equal to 0. So x minus 10 equals 0. X plus 1 equals 0. Add the 10. X equals 10. Subtract the 1. X equals negative 1. Again, I got to check. So what I'm plugging it into was log x plus log x minus 9 equals 1. Well, when I plug in the 10, this is good. 10 minus 9, that's 1. That's good. So that one's good. But as soon as I plug in negative 1 right here, it makes that first one negative. So get rid of it. So the only good answer is x equals 10. So for number 25, it's got log x equals log x, the square root of it. So what I want to do is get rid of the square root. You could also turn it to a fraction exponent if you want, but I'm just going to cancel that. So now I'm left with log squared x equals log x. Because we're squaring the log, not the exponent. So it's this log x, which turns into log squared x. No. So then now what we're going to do is we're going to move it over. I'm going to subtract log x from both sides. And I'm going to factor out a GCF. So log squared x minus log x equals 0. And then now factor out a GCF of log x. And I'm left with log x minus 1 equals 0. Set each factor equal to 0. So this one equal to 0. And then this one. For the first one, I can turn it into exponential. Remember, there's a little assumed 10 here. 10 to the 0 power equals x. Remember, anything to the 0 power is 1. Over here, I have to add the 1. Log x equals 1. Again, assume a little 10 here. So 10 to the first equals x. So x just equals 10. And again, it's not going to make anything negative. So what I did up here is I factored out a GCF of log x. And that's what went here. And then after I divided, what remained in the parentheses was the log x minus 1. All right, so for this one, again, now, I know I had said if there's a log on the left and a log on the right, we can cancel it. But we've got a term here that doesn't have a log. So what I need to do is I need to get my logs together and I need to condense. So I need to subtract this log and put it over here with this one. And then I'm going to condense it. So now I have log 11x plus 9 minus log x plus 4 equals 3. I now can condense. The subtraction sign tells me division. So log 11x plus 9 over x plus 4 equals 3. So remember, when it doesn't have a little base here, it's assumed to be a 10. So it's spelling bay, I'm going to B. So 10 to the third is equal to 11x plus 9 over x plus 4. I can put a 1 under here, and I'm going to solve this as a proportion. I'm going to go over to the side. So I'm going to change to the 10 to the third power, and I'm going to make it 1,000 over 1 is equal to 11x plus 9 over the x plus 4. I'm going to cross multiply. So now I end up with 1,000x plus 4,000 equals, and nothing to distribute, it's times 1. So it's just going to be 11x plus 9 when I do the other diagonal. I need to get my like terms together. So I'm going to subtract 11x from both sides. And I get 989x plus 4,000 equals 9. I need to subtract the 4,000. And I get 989x is equal to negative 3,991. And then now divide both sides by 989. And once you do that division, you're going to get, and I get negative 4.035389282, but rounded to 4 places, the 9 tells the 8 to go up. So negative 4.03539. Okay, so for number 27, this is not a log equation. Now, also, wait, we needed to check this one. However, what I'm plugging this number in to check is 11x plus 9 and the x plus 4. So on this one's going to make them all negative. So this one, there is no solution. Good thing I remembered this. Let me go back here. So when I plug this in, this is going to give me, when I multiply this, the negative 4.03539 times 11 is going to give me negative 44.38929. And when I add 9 to that, it's going to give me a negative number. So I can stop. I really don't even need to check it there. But if you recognize that when you're adding positive 4 to negative 4 point something, that's going to be negative as well. So this one is actually no solution because it doesn't work. After all of that long division, it doesn't work. All right, so now back to number 27. This one is an exponential equation. It's not log, so it's from the beginning examples from the notes. So let me rewrite it up here at the top. So I have lots of room. So I have 6 raised to the x minus 3 power, and then 3 raised to the 4x plus 1. Now remember, whenever it's exponential, if you cannot make the bases the same, then what we're going to do is we're going to add ln to both sides. So I'm going to add an ln in front, and then I'm going to apply my power property, and I'm going to pull this power in front. So I'm going to pull this x minus 3 to the front and the 4x plus 1. So now I have x minus 3 times ln 6 equals 4x plus 1 times ln 3. Remember, you need to distribute. So I need to distribute the x to the ln 6 and the 3. So it's going to become x ln 6 minus 3 ln 6. Then the right side, distribute the 4x and the 1. So 4x ln 3 plus just ln 3. So now remember, we need to get our x's together and then our constants together. So what I can do here is subtract the 4x ln 3 from both sides. And then I get x ln 6 minus 4x ln 3. I still have this constant that I'm going to move, equals this other constant. So then now I'm going to add the 3 ln 6. And then now I'm left with x ln 6 minus 4x ln 3 equals ln 3 plus 3 ln 6. So on the left side, divide both of these by x. And now I'm left with ln 6 minus 4 ln 3. And then it equals the purple. ln 3, 3 ln 6. And now last step is just divide by this that's in the parenthesis here. So divide both sides by ln 6 minus 4 ln 3, ln 6. And again, I would enter this as a fraction. So this is what you're entering into your calculator to get that x is equal to negative 2.4873. Okay, so let's try the last two. Let me go ahead and just rewrite 28 down here. So 28 ln e to the x minus 2 ln e equals ln e to the 4th. Okay, so again, don't be tempted to go ahead and try to condense down. Now you could recognize and apply your power property, pull this into the front, and then now what we have is x times ln e minus 2 times ln e equals 4 times ln e. And remember, all of these equal 1. So then what we've got here is x times 1 minus 2 times 1 equals 4 times 1. So x minus 2 equals 4. And then add 2, and x equals 6. And for the last one, let me rewrite it. There's other ways you could have done that one, but that's really the easiest way. So then here, log base 2, and then it's the square root of 2x squared equals 3 over 2. Now right now, we're in Bay. So let's go ahead and we can go ahead, this is B, A, E. Let's go ahead and turn it into exponential. So if we do 2 raised to the 3/2 power is equal to 2x squared under the square root. I'm going to go ahead and change the square root into a fraction exponent and make it to the 1/2 power. And then now what I could do is I could raise both sides to the 2nd power, which really cancels the fraction. And then now I'm left with 2 to the 3rd equals 2x squared. I need to go ahead and evaluate 2 to the 3rd, it's 8. And then now I can divide both sides by 2. And then 8 divided by 2 is 4 equals x squared. Just use your square root method. And x is equal to positive and negative 2. Now remember, we started out with a log, so we got to check it. So the original problem was log base 2x squared equals 3/2. And they're both going to work because it's not going to make this negative here, because once I plug a -2 into a square, it's going to turn positive. So both of these are good answers. And that's the end of the 5-4 notes.